All right, good morning, good morning, good morning. Today we're going to be talking about exponents, and these exponents are going to be having fraction as their exponent, okay? So when I look at this really carefully, I see that it has an a over b. If I think about fractions, fractions are parts of wholes. If I have a number like 1 over 3, okay, I would have a circle, and I would be able to split it into 3 pieces. 1, 2, 3. If I wanted to, I could make that even a little more different. And I can change that 1 over 3 to potentially 1 over 4. And when I do that, I go, okay, I have 4 pieces. I could do it 1 over 5. And as I make it 1 over, as that denominator gets bigger, the fraction gets smaller, right? I can do the opposite too. If I start talking about having 1 out of those 4 pieces shaded red, well, that's interesting. I could even change that now towards the number 2. And if the 2 of those are shaded red, well then that's a much bigger area. If I made it 3 instead of 2, it's getting even larger. So this fraction has ways to make the pieces that it is describing smaller, as well as the number of pieces being more. So you have parts that are trying to make the fraction bigger, the numerator, and parts that are trying to make the fraction smaller, the denominator. And the same thing happens with these roots, okay? A is the numerator. It is trying to make x bigger, and so it stays above x, trying to make it bigger. B is the denominator. It's trying to make x smaller, and so it actually goes in a root in front of x in order to try to make it smaller. In real terms, if we think about this, like if we had the number 4 raised to the 2/5, what I would be able to say with that is equal to 4, and I look at the numerator and I say, okay, that's the number 2. That 2 stays above 4, trying to make it larger. I say, okay, the denominator, what's the denominator? Well, that was the 5 we talked about. That 5 goes here inside the roots, and we can actually take that and go into our calculator and get this typed in, right? So like, here's my calculator. If I get it turned on, I push enter to go ahead and clear out of this screen right here. You'll see I have one up here from when I did a failed attempt earlier, okay? But we'll go ahead and do the same thing here. What we just typed in was the square root, not the square root, the 5th root of 4 raised to 2. In order to get this typed in, I'm gonna push Control, that yellow button there. And if I look really closely at my button here, you'll see where it has an n over x in yellow above it. If we click it, you'll see it gives us the chance to type stuff in. We had a number 5 out here. We had the number 4, and it was raised, I'm using this arrow right here, to the 2. And this looks like what we just used, 1.471. That is the same as if I had 4 raised to, in the parentheses, 2 over 5, or 2/5. I hit enter, and it gives me the exact same number, because that's what we are trying to do. We are trying to actually take our fractional exponent and rewrite it to where it looks like roots, okay? So let's go ahead and run to a couple of these examples and get it done real quick. For this 6 raised to the 1/3, I'm going to go 6 raised to the 1, which I actually don't need to put that 1 above the 6. I'm not gonna fight you if you do, but again, that 1 above the 6 is invisible. The 3 goes out here, and for that, I'm actually gonna wanna go to my calculator, type it in, and see what I'm able to get. So if I go back to my calculator, friend, and I go, okay, Control, that yellow button, the arrow to get this. It is the 3rd root, use the arrow to go next to it, of 6. It gives me 1.817, which I am just going to round to 1.8. For the 62p, the 2/5, the 2/5 is only being applied to p. It doesn't actually need to get applied to the 62 because that exponent is only applied to the base that's right next to it. So that p is going to get the 2, which is trying to make it bigger. It's going to stay trying to make it bigger by being p raised to it. And then the 5, which tries to make it smaller, is going to be the 5 that goes out here. And that's the most that we can do to simplify this. The 9p raised to the 3 halves, we're going to rewrite. Since it's in parentheses, the 9p, all of that is going to be squared. And it's going to be raised, excuse me, not raised, it's going to be third rooted. Now, since that 9 is inside the parentheses, we can try to take it apart. We can try. If we go back to our calculator, we can apply the 2 power and the 3 to it. If I hit the yellow arrow and I hit 9, ooh, delete. It's not 9 that goes there. Mr. Ring, you're being dumb. All right. It was the third root of 9 squared. And I hit enter and I get the number 4 point. Okay, that's not going to help us because it doesn't give us a whole number. Since it doesn't give us a whole number, we're going to leave this as the answer. I have a negative fraction. And in this case, we're going to apply our new step as well as one of our old ones. Yes, we are going to take our 81p and we're going to put it underneath in a square root. It's still going to be raised to the 4. It's still going to have a 3 here. But since it's negative, it goes underneath this fraction. 1 over the third root of 81p to the 4, which has to be in parentheses because 81 gets raised to the 4 before it gets that third root applied. And we can do the same thing kind of backwards, where when we're giving these, we can write it as 5 raised to something. Once again, if I look at this and try to decide what is making it bigger, it's that 5 right there. So I put that 5 in the numerator of this fraction, and the thing that's trying to make it smaller is that 4. So that 4 goes in the denominator, okay? This is going to be my fraction, 5 raised to the 5 over 4. The 8th root of 7 is interesting because while I do have the number 7, it is going to be raised to a fraction. 7 has that invisible 1 above it. It is trying to be raised to that 1. And then 8 next to it is trying to make it smaller. So I go, okay, 1 over 8. It is the 8th root of 7. 5 root 3. This one is one that is going to be something that you do need to kind of memorize. Because whenever you have that square root and there's an invisible number here, it's actually the number 2. Not the number 1, the number 2. 2 is the denominator because that's what my root is. The 3 is what 5 is trying to be raised to, so that goes on top. And then with that 10, everything's invisible. That 10 is trying to be raised to the 1. It's invisible. It's got the invisible 2 in front of it as well. I'd like you to take your worksheet and I'd like you to complete it as much as you can. Thank you.